80 problems are given in the description of this video. Most of them has been collected from entrance exam like JEE, IIT, PSC, School Service, NET, GATE. I will solve this problem with some shortcut tips. I hope you will like this video. So let's start without spending much time. At first, I discuss the problems which the correspondence does not form a mapping. Here, the function like a machine, there are two cases f does not form a mapping. First case, if x belongs to df, then if it has no f images, that is either fx does not belongs to B or fx does not exist. In this case, f does not form a mapping. So let us come to the problem which are given in my description. 80 problems, each of MCQ type, and this option are given. Now for the problem 1, if A to B, suppose A, B are given, A 1, 2, 3 and B is ABC. Here the given mapping correspondence 1 to A, 3 to B, but 2 has no mapping. 2 does not correspondence any of the element of the codomain. 2 f of 2 does not given. Therefore, it is not a mapping. It is not a mapping. That is the option is E. Now let us come to the second problem. Now third problem. At first I do third problem. Given f z to n. F z to n. Z means all the elements are -3, -2, -1, 0, 1, 2, 3, set of all integers, and another to the codomain set is natural number n, that is 1, 2, 3. Here the correspondence is fx equals 2x plus 3. But if we take the value of x, suppose -2, therefore f of -2 equals -4 plus 3 equal to -1. But -1 does not belongs to the n codomain set. F of it does not belongs to n. Therefore, it is also does not form a mapping. Let us come another problem. For f r to r fx equal to log x. F r to r fx equal to log x. Here you can easily solve this problem for well-known curve. Here log x is the curve this. Fx equal to log x. Domain is the real number. This is real. That is domain d of f positive. In this direction d of f negative. If we take any negative real number that is equal to -2, then f of -2 equals log of -2 is not a real number. It is a complex number. Therefore, it does not belongs to R. So it is also does not form a mapping. So that is the option is E. Now let's come to another problem 2 and 5. The second condition f does not form a mapping is if x belongs to df has more than one f images. That is, if x gives the images, suppose f of x1, again it gives another images f of x2, x1 dash. Therefore it has S cannot be more than one images. Therefore in this case Fx diagonal form mapping. Now the problem 2. For the problem 2, A and B are given. F is mapping F12 and B ABC. The given correspondence is 1 to A, 2 to B, again 2 to C. F of 2 has two images B and C. This rule is not a mapping. Therefore, it is the option. This option is answer is C. Now let us come to another problem. 5 y square equal to fx. For y equal to fx, for all xy belongs to R. This is a very interesting problem. 5 we write fx equal to y equals plus minus root over of x. Y equal to fx. This is if we draw the graph. This is of the form y square equal to x. That is this. Now for x equals 4, you give two images 2 and minus 2. That is 4 corresponds to images 2 and minus 2. This rule is not a diagonal form mapping. Also, we can say if a line parallel to y-axis cuts the curve more than 2 points, then this type of function or relation is not a mapping. Also, this type of curve, diagonal form mapping. Let us come to the problem 1-1 mapping, that is injective mapping, 1-1 into or onto. At first, I discussed this type of problem which the sets of domain, the elements of the domain and codomain are discrete type of elements, that is n to n or z to n. Now, for the sixth problem, the domain is 1 to and codomain is ABC. Mapping is 1 to A and 2 to C. That is 1-1 correspondence. Only one has the only images A, 2 only C. This is the case of 1-1. Also, it is into case because here the element B is excess on the codomain set. Therefore, FA, that is the image set AC, this is with the subset of the codomain set B. Therefore, the result is 1-1 into. Now, for the seventh problem, if n to n, fn equal to 2n plus 3 for all n belongs to n. Here, the domain set is a natural number, also codomain with the set of all natural number 1, 2, 3 up to this, 1, 2, 3 up to this. Here, for 1 gives 5, 2 has the f of 1, f of 2 has the images 7 and so on. So it is also 1-1. But into or onto, if fn fn equals suppose 6, then 2n plus 3 equal to 6, or n equals 3 by 2, which is absurd. N is a set of all natural number. So here also 6 or any other element has no f images. 6 has no f images, since f of 6 equals 6 has no pre-images. 6 has no pre-images. If this is 6 has no pre-images. So it is also 1 into. Now for the problem 8, fn equal to n square. For the problem 8, f of 1 gives domain, codomain. 1 also give the result 1 square 1, 2 give the result 4, 3 gives the result 9, and so on. But here the elements of this 2, 3 or 5 and so on, all the elements has no pre-images. So the elements of the codomain set eta, these 2, 3, 5 has no pre-images, therefore it is also into. In this case 9, f q to q, fx equal to this is also 1 mapping, because this card is of the form this. For all the elements for the q, we get the first different elements of this of the codomain set. Defines p images, therefore defines images, therefore this is also 1. It is not into. Suppose we take f of x equals 6, then 2x cube plus 3 equal to 6, or x cube equals 3 by 2, or x equals 3 by 2 whole to the power 1 by 3rd. X equal to this. Thus, in the codomain set, if we take the element codomain set 6, it has no pre-images. Because 3 by 2 to the power 1/3 is not a rational number, it is an irrational number. So this type of elements are also excess, therefore it is also into. This problem 10 is similar to the problem 8, so it is also the result A. Now for the problem 11, when the domain and codomain is of the form R to R or any of the continuous cases, we test for these two tips. Now fx equal to x by 1 plus x, therefore f dash x equal to 1 by 1 plus x square, which is also greater than 0, that is strictly increasing. In this case it is 1. Strictly increasing in this case we can solve easily in the graphical method. Suppose this is a curve, so strictly increasing means x1 x1 not equal to x2, f of x1 not equal to f of x2, or in applying f dash is greater than 0 or less than 0. So f dash is greater than 0 strictly increasing, therefore it is 1. Now we show that either it is into or onto. Suppose y equal to fx equals x by 1 plus x. Therefore, x equal to y by 1 minus y. Only 1, y equals 1. When y equals 1 in the codomain set, 1 has no pre-images. 1 has no pre-images, therefore this is not into. Therefore this is not onto. Therefore it is also 1 and into. Let us come to the problem of 1 and onto problem, that is bijective problem. Here we discuss the problem 12. For known curve, if you draw the curve, you can easily, without writing, you can easily find the answer of this problem. Suppose the known curve, if you draw this curve, is of the form this. Here, this represent domain of positive side, and this side is domain of negative side. This is the range of positive side, and this is the range of negative side. Now, if R to R, this continuous curve, always for all values of x, positive x, you can get the defined values of range of plus f. Also, you can say f dash x equal to 3x square plus 1. This is also greater than 0 for increasing curve. And also negative side of df, that is this, you can get all the values of negative of range of f. So you can easily say that d of r of f equal to total real number. It is 1 for the increasing curve, and range, total range r plus r minus equal to the union of these two is equal to the set of real, that is codomain set. Therefore, it is 1 and 2, that is bijective mapping. 1 and 2, that is bijective. Similarly, for the same problem 13, the domain and range are in the 0, 1, minus 1, and this is 1, minus 1. 1, and this is minus 1, minus 1. So, range increasing curve, range also plus 1 to minus 1, and the domain set is the minus 1 to plus 1. Now, for the 14th problem number 14, if we draw the graph of this, fx equals x mod x, that is equal to minus plus x square for x greater than equal to 0. This is equal to minus x square if x less than 0. This is the two curves. One, x square equal to y, x square equal to y means this part is not included. This is a parabola. Again, this portion is not included. This graph for x greater than equal to 0, for x less than equal to 0. So it is also the increasing graph, and it is 1 and 1 2 also, like the problem 12, 13. Now problem 15 is too easy. 1 2 3 A B C. 1 maps A, 2 maps C, 3 maps B. So it is also 1 1 and it is also 1 2 because it has no excess element. Therefore, it is all the option are B. Now comes to the problem 16, which is solved in all the books of mapping. 16 problem is a straight line, so it is also a increasing and also a mapping increasing curve is also a mapping for pre-image at f of f dash x equal to 2 greater than 0, that is 1 1, and y equal to fx. If we take y equal to fx equal to 2x minus 3, therefore x equal to y plus 3 by 2. For fx equal to y plus 3 by 2 gives the images y. Thus, if y belongs to the Barddhaman set, then y plus 3 by 2 also belongs to a real in the Barddhaman set. For all y must have a pre-image, therefore it is 1 2, and the result is 1 1 1 2 B. 17 problem is similar to this because this is the odd part of x. This type of problem, if f comes from R to R or this or R minus this, then fx equals ax to the power n plus b. If n is odd integer, then this type of function is also a bijective. 1 by x is also bijective. e to the power x, a to the power x, log x. You can sketch this graph and easily find the result. Now for the problem 18. Fx equals this. Now we can find f dash x also, always this greater than 0, therefore it is 1 1. If y equals 2x plus 5 by 3x minus 1, you get x equals 3y plus 1 by 3 minus 2y. If y not equals 3 by 2, here is restricted interval 3 by 2 in the Barddhaman, and the domain set minus 3 by 2 is not present. Therefore, for all y, it must have a pre-image if of the form 3y plus 1 by 3 minus 2y. Therefore, this is also 1 1 1 2, that is bijective. Now 19 and 20 are similar problem. These are in the problem of WBJE, and also this is in an IIT. Now we solve this problem. Here for the problem 19, domain, Barddhaman. This is A and this is Z. We divide domain set into two parts. One is given n odd, n is even. N odd means 1, 3, 5, 7, and you get the images for 1, n minus 1 by 2, that is 1 0, 3 1, 5 2, and so on. Also for the even number, even n 2, 4, 6, 8, you can get n minus n by 2, that is you get minus 1, minus 2, and minus 3, and so on. So Here f of n equals to set of fn equals to z. Therefore, it is onto also. Therefore, the answer is B. You can try this problem by similar method. For the rest problem, stay updated for the next video. So this much for today. Meet you in the next video. Check the questions in the description. Until then, take care. Goodbye.